Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. All right, tonight I'll be doing the review for test 4. I can get that finger fixed one of these days. And let me just remind you, test 4, I will be giving this Wednesday morning. I'll send out the email with the password for test number 4. Now, because of the Thanksgiving holiday, I can't have you handed in on Friday because there's no school. ECC is closed starting at 5 o'clock Wednesday until Monday morning when they open up again. By the way, I'd like to wish everybody a happy Thanksgiving. Now, because of this, you'll have until Monday, next Monday, the 2nd of December, 8 p.m., to finish your test number 4 and upload it to the assignment area D2L. It should take about 40 minutes, but take as much time as you need. Test number 4 will cover polymers, lipids, otherwise known as fats and oils, and carbohydrates. It has 9 pages, 20 problems. And some of the problems have multiple parts. In Chem 170, I've never had a multiple choice question on an exam or final. Now, the points breakdown is a little different. Oh, look, 54 points, general knowledge. What does that mean? I'll talk about that in a second. 15 points, nomenclature, and only 36 points, reactions. And it adds up to 105. So there's 5 bonus points. You pick which problems you want. Now, why is there so much general knowledge points? Well, if I ask, is your right hand chiral or achiral? Well, that's not nomenclature. It's not reactions. So it must be general knowledge. If I ask you to draw the enantiomer of a molecule, well, that's not nomenclature. That's not reactions. It must be general knowledge. So that's why there's so many points general knowledge, because a number of questions in polymers and carbohydrates are not really nomenclature, are not really reactions. So I call it general knowledge. Now, one other thing I want to remind you, the optional extra credit project, the deadline is this coming Monday, the 2nd of December. And if you look in the assignment area of D2L, you'll find it and there's instructions. Now, as a special public service to all my students, before the 2nd, that Monday, email me your project. Remember, it's optional, but I'll tell you if anything needs to be corrected. And therefore, there's no reason each of you shouldn't be able to do that project to get 10 bonus points. It's not that hard. You can go look in your refrigerator in your kitchen, or you look in your bathroom at some of your personal care items. In the video, and I'll give you 1 point right now, you can find some others here too. Carmex, if you look on the label, it has phenol. And if a molecule has more than one functional group, you only have to name one. And in Carmex, you have phenol has a benzene ring. You could have put that. Phenol is an alcohol, either one of those. So you all should be able to get 1 point. Carmex, phenol, either alcohol or benzene ring, or you could also say aromatic ring. All right, let's go through the review for test number 4. Now, what you see on the screen is available in D2L in the lecture section of D2L folder, and it's cleverly named test for review. I also have it as a PDF file. All right, let's go through things you should know. First of all, what is a polymer? It's a macromolecule. That means it's a big molecule made up of repeating units called monomers. Now, you should know there are two different ways of classifying polymers. One is by its chemical property and the other by physical. When we have chemical property, you should know an addition polymer is a polymer with only one type of monomer. And you should know examples of that would be rubber tires or plastic or saran wrap, which is a brand name. Now, a condensation polymer, you're bringing a polymer with two different types of monomers together, not all the same. And so that's a condensation polymer. An example of that would be my water bottle. This is a polyester condensation. I have down in my closet a nylon jacket, and that's an example. Now, the other type of property are physical properties, and there are two types. One is thermoplastic, and you should know once formed, it can be reheated and reshaped, like this plastic bottle, and also saran wrap. There's no correlation between thermoplastic and whether it's addition or condensation. They're two separate things. Now, thermoset, once you make the polymer and make it into a shape, you cannot reheat it and reshape it. Example, that would be rubber tires, like car tires, or urethane foam, like the insulation in your refrigerator. And that's all I'm going to ask about polymers, even though I could do a whole semester, 2-semester course on polymers. Dr. White's work with polymers in industry. All right, next I'd like to talk about fats and oils, and there are a few definitions you should know. Now, a lipid are molecules that come from plants and other living things like us that are soluble in nonpolar solvents, but not in water. Now, when we look at lipids, there are two types you should know. One is saponifiable, which we also call fats and oils. And you should know that yields the carboxylate anion of what I teach you in this chapter, fatty acids, in a reaction with base and water, like saponification of an ester. Now, the other type is non-saponifiable lipids, and they're also called your steroids. I think I have some in me somewhere. And these do not react with base and water. They're non-saponifiable. You can't saponify it. Now, let's talk about fats and oils. You should know a fat is a solid or semi-solid triglyceride at room temperature. An oil is a liquid triglyceride at room temperature. And my cardiologist reminded me, keep your fats and oils intake way down. It's healthy for you. Now, the general structure for all fats and oil is this triglyceride, also known as a triester. And for test 3, you learned an ester. Synthetic organic chemists write it this way. Fats and oils chemists, otherwise known as oil chemists, either though the oil is not petroleum, it's oil from fats and oils like olive oil, write their ester this way. If you notice, here's ester number 1, 2, 3. There are 3 esters in all fats and oils. Now, as I promised, no new, essentially, except for one slight wrinkle, no new reactions. If you have acid hydrolysis of a fat or oil, that's what happens in your stomach. We take an ester, acid, and water, H plus water, get back the alcohol and the carboxylic acid you would have used to make that ester. So if I take this triglyceride, any fat or oil, and the R groups can be the same or different. We'll talk more about that in a little while. The first ester gives this alcohol plus this carboxylic acid. Second ester gives this alcohol plus this carboxylic acid. And the last one gives this alcohol, and they're connected together, and we call this glycerin, plus this carboxylic acid. Now, the carboxylic acids that come from hydrolysis of an triglyceride used to be called fatty carboxylic acids. And organic chemists are lazy. So instead of saying fatty carboxylic acids, they shortened it to fatty acids. But it is a carboxylic acid, come from fats and oils. Now, for base hydrolysis, you can have an ester, and then for the base, I'll use sodium hydroxide. You can use other ones. And water, you get back the alcohol, but the carboxylic acid reacts with the base to give the carboxylate anion. So ester number 1 gives this alcohol plus this carboxylate anion. Ester number 2 gives this alcohol plus this carboxylate anion. And ester 3 gives this alcohol, and you get glycerin again, plus this alcohol. And I worked for a company that did the first reaction, and I'll show you another one they did right now. Now, how do you make a reaction go quicker? Because time is money in industry. Well, one way is use a catalyst, like acid or base. The other way is there's a rule of thumb that for every 10 degrees Celsius, most reactions you heat, you double the reaction time. So if you run for most, not all, but most reactions, higher temperature, it goes faster. Well, what's really hot water? Steam, especially high pressure steam, quite dangerous stuff too. And steam, you have steam hydrolysis of fat or oil, your ester, hot water, steam, gets the same products as acid hydrolysis of an ester, alcohol plus a carboxylic acid. So if I have this ester, I'll get this alcohol plus this carboxylic acid. This ester gives me this alcohol plus this carboxylic acid. And this ester gives me this alcohol. And again, you get glycerin. That's the common name everybody calls this. Plus this carboxylic acid. Now, there are 2 key fatty acids. You should know the name and structure, the common name. And Dr. White worked at a company where I was laboratory manager, both research and the quality control lab I managed. And we made stearic acid, which was 18 carbons. And now I'm going to use the parentheses so you don't have to write CH2 16 times. And that's stearic acid. And then that's a saturated fatty acid, meaning there's only carbon-carbon single bonds. Now, oleic acid also has 18 carbons, but at carbon number 9, remember the carbonyl carbon is 1, at carbon number 9, there's a double bond, and that can be cis or trans. And you have a total of 18 carbons, but the double bond here, and that's oleic acid. And I work for a company, and we made about 2 to 3 million pounds each of stearic and oleic acid every week. Yes, a couple million pounds of each every week. Now, as I said, the stearic acid is an example of a saturated fatty acid found in saturated fats. And a saturated fat has only carbon-carbon single bonds. Still has a carbonyl from this ester, but the R group only has carbon-carbon single bonds. Unsaturated has at least one carbon-carbon double bond. I should remind you, Mother Nature, probably the greatest chemist, organic chemist of all time, never ever made anything with a triple bond. That's something organic chemists did, not Mother Nature. So all fats and oils only have double or single bonds, carbon-carbon. Now, something you should know, since I worked in this industry for a number of years, and I'm passing some knowledge that's not really good in the book, and that is you should know tallow is called beef fat. And yellow grease and white grease are two different grades of pig's fat. And I worked at a company, we would purchase a couple million pounds of each every week. In fact, one of the jobs I had, the president of the company in the United States, was an international company, said, our sister company in Europe needs tallow and are having trouble buying it at a good price in Europe. Work with the purchasing manager and make sure, I think we shipped them 10 million pounds of tallow. And I had to ensure that it was loaded in a deep sea tanker in New York Harbor. And we were located in Chicago, but we bought it in New York, that what we shipped them was good. Once it was in the tanker, it was still good. And then once it arrived in Rotterdam, I had a company sample it and take measurements, and also FedEx me a sample so my lab could check it. We did that with New York too, to make sure it was still good. And it was. That was a lot of money involved too. All right, now, to make life real with this chapter, I came up with the following. A good approximation for tallow, white grease, and yellow grease is this: triglyceride, where the first R group is sterile. That means if you hydrolyze this, you get stearic acid. The second one is allelyl group, double bond there. If you hydrolyze this, you get oleic acid. And the final one is again a sterile, because how do you do 50-50 of each, which in tallow, white grease, and yellow grease there is approximately, when you have three here. It's more complex, but I simplified it. Also, a little joke, SOS, save our chip. All right, therefore, you should know if on a test I have tallow reacting with sodium hydroxide and water, what three products do you get? Well, this is tallow is a triglyceride and ester. You get alcohol plus carboxylate anions. But when I say tallow, you should know, you should write this down. Same thing if I say yellow grease or white grease here. And what I'm really asking is take this molecule, react it with sodium hydroxide and water, which is this general reaction, first ester gives this alcohol plus this carboxylate anion. Remember, R is R sub S. This ester gives this alcohol plus this carboxylate anion, where R here is R sub O. And this is shorthand for oleic and sodium oleate, sodium stearate, sodium oleate. And the last one here, you'll get this alcohol, you get glycerin, and you'd get this one. Now, since you don't balance equations in my class, you don't have to put a 2 here. That's why I have it in quote. But if you notice, there are three different products, even though there are two of here. There's glycerin, sodium stearate, and sodium oleate. And you should know how to do the same thing with acid and water and steam. Now, one of the important things I would like you to know leaving my class: how does soap work? And you should know the structure of soap. All soaps and detergents have a nonpolar tail and a polar head. Now, dirt and grease are polar, and I don't have down here, and I should. Water is polar. And the key to this is like dissolves like. And what that means is things that are polar are soluble in polar things. Things that are nonpolar are soluble in nonpolar things. You mix the two together, polar, nonpolar, they're not. Just like oil, vinaigrette. Now, soap is called a surfactant because it has a nonpolar tail and a polar head. So if we have a piece of dirt here, which is nonpolar, because the light dissolves light, the polar tail is attracted to the dirt, but the polar heads stay far away. And this totally surrounds the dirt, and you should know this forms a micelle. And you should know what a micelle is. Now, once you have the micelle, the dirt is surrounded by the soap molecules where the polar heads are on the outside. And water looks at the micelle and says, you're polar, I'm polar, let's go down the drain together. And they do. And that's how you get dirt off your hands. You should know this. Now, non-saponifiable lipids are the steroids. And you should know how to draw this general steroid structure. 6, 6, 6, 5. All your steroids, your hormones have that structure. All right, let's move on to carbohydrates. First of all, what is a carbohydrate? It's a polyhydroxyl aldehyde. Now, poly means many, and hydroxyl group is OH, so it's an aldehyde with a lot of OH groups in it, or a polyhydroxyl ketone, or a molecule upon hydrolysis becomes a polyhydroxyl aldehyde or ketone. Now, at this point, we have to talk about chirality. And you should know the word chirality means handedness. It's in Greek. And I actually, a number of years ago, one semester, had not one, but two students who spoke Greek. And they said chiral means handedness. Now, it turns out in life, there are two types of objects, achiral and chiral. And a chiral object is an object with a superimposable mirror image. Let's assume these two erasers were identical. They're not, but if they were, these were mirror images, and I can push them together so everything lines up. And if it has a superimposable mirror image, like this does, if it were identical, we would call that achiral. The prefix A means without handedness. And a chiral object is an object with a superimposable, non-superimposable mirror image. And that means it has handedness. And turns out molecules can be like that. But, oops, that's not what I want. That's what I want. If we look at our hands, forget about the ring, they're mirror images. And they're not superimposable. Forget about the ring. If I have my thumb here, nothing else lines up. If I have my two long center fingers, nothing else lines up. Or if I do my little pinkies, nothing else lines up. Mirror image, non-superimposable. My hands are chiral. Now, in the problem set, I ask you certain items, are they chiral or achiral? And you have to determine, does it have a superimposable mirror image or not? I went through that in the video, And I also have that in the problem set, what I went through in the video. Now, one hint, if in the name of something you see the words right or left, you immediately know it's chiral. In the name of something, if you see right or left, it's chiral. So if I say, is my right shoe chiral or achiral? Well, you see right shoe, right, that tells you immediately it's chiral. And you got to see in the video me doing artwork and showing you I have no art talent whatsoever. Now, another important thing is a chiral carbon. And that's a carbon with 4 different groups, 4 different atoms, or a combination of 4 different groups or atoms. Now, if a molecule has a double bond in it, then the carbons here are not chiral carbons. Same thing with this. Again, this is not a chiral carbon. If it has 2 or more hydrogens, it's not. If I look at this molecule, and if I were to ask to circle the chiral carbons, this has 3 hydrogens, so it can't be, it's out. This has 2 hydrogens, it has 2 or more hydrogens, it's out. Can't be chiral carbon. This one has 3 hydrogens, it's out. Now, this one right here is in a double bond, so it's out. Same thing here. So if we go back and look at this carbon, it has a hydrogen, hydroxyl group. Let's call this methyl R, and all this R prime. Therefore, it has 1, 2, 3, 4 different groups, atoms, or a combination thereof. Therefore, this is the one I would circle as the chiral carbon. And I have examples of that in a practice problem set. Now, there's something called enantiomers or enantiomeric pairs, and they're important in our daily life. And what is an enantiomer? It's the non-superimposable mirror image of a molecule. So if I were to ask you to draw the enantiomer or something, at this point I talked about Fisher projections. If I were to ask you to draw the enantiomer of this molecule, remember each intersection here is a carbon. So what I'm really asking you is draw the mirror image. Now you don't have to do it, but I put in my mirror as a mnemonic device to help me do this. And we're going to have this. Now this carbon is achiral, so I just have to draw it. This is achiral, it's got 2 or more hydrogens, so I don't have to draw the mirror image. But this carbon, what's close to the mirror is what you see first, and that's the hydrogen. What's farthest away is the hydroxyl group. On this carbon, what's closest to the mirror? This. What's farthest away? This. And this would be the enantiomer, the answer, if I ask you to draw the enantiomer or something, which means draw the mirror image. Now, a reaction that you learn for test 2, if you take an aldehyde or ketone, react with an alcohol with acid, you get a hemiacetal. Now, if you have two functional groups in the same molecule, you don't need a catalyst because it's in the same molecule. Therefore, on carbon C5, this hydroxyl group reacts with decarbonyl and glucose to form this hemiacetal. And instead of having you learn Hawthorne projections, I came up with this longest, ugliest oxygen carbon single bond, but it makes it easier for you to do. You should know this equilibrium. If I give you this, you should know how to draw the product. If I give you this, you should know how to draw the starting material or write the name. Now, the same thing can happen with fructose. These are both sugars, which are carbohydrates. And here we have a ketone. Again, same reaction, making a hemiacetal. Hydroxyl group on carbon 5 reacts, everything else stays the same. And this carbon here is this carbon right here. And you should know, if I give you fructose, the structure, how to draw its hemiacetal. If I give you this hemiacetal of fructose, you should be either able to draw fructose or write its name. Now, there's a reaction which is slight wrinkles, a little bit new. I taught you if you took a ketone or aldehyde, you could go all the way with 2 alcohols to make an acetal or ketal. But turns out you can stop in the middle. Instead of having the second alcohol, the same thing, you can do a different alcohol. And here we have a different alcohol. If you take the hemiacetal of glucose, you react this hydroxyl group with alcohol and acid and replace it with OR. So the only thing you're changing is OH to OR. And this reaction allows Mother Nature to connect many glucose molecules together to make starch. So you have the good things in life like bread, pizza, French fries, potatoes, rice. Now you should know sucrose, which is table sugar, is a fructose and glucose molecule bond together. And starch are many glucose molecules bond together in a acetal linkage. And because of that, if you take glucose and react it with acid, you'll make starch. And the linkage between starch molecules is an acetal. So if I take, and the same thing with sucrose, acid, and water gives fructose and glucose. Know the names, not the structures. If I take starch and in your stomach, guess what happens? The acid, hydrochloric acid, and water break that down to glucose, which is the sugar in your blood. Now, leaving my class, hold on, says no, time for Dr. White to get really, really subtle. Let me print it a little better. All right. Leaving my class, you should know how to describe with words and a general reaction what happens in your stomach when you eat a fat or oil. And all fats and oils, the functional group is an ester. And because of the acid and water, the reaction that breaks down fats and oils is described as acid hydrolysis of an ester. And for test number 3, you learned ester, acid, and water. To get back the carboxylic acid and the alcohol you should have used, you would have used to make that ester. So when you eat a fat or oil, you should know how to describe with words and a general reaction what happens when you eat a fat or oil in your stomach. And with words, that's acid, hydrolysis, and ester. With general reaction, ester, acid, and water give a carboxylic acid plus an alcohol. Now, you should also know what happens in your stomach when you eat a carbohydrate. What holds the glucose molecules together? An acetal linkage. And the acid and water, acid hydrolysis, you have acid hydrolysis of an acetal. And for test 2, you learned an acetal or ketal plus acid and water. You get back the aldehyde or ketone plus the alcohol you would have used to make that acetal or ketal. So again, being subtle, hint, you should know this. You should know how to describe with words and a general reaction when you eat a fat or oil, what happens in your stomach. I think someone also corrected me. It also happens in another part of your body. I think it's your colon or smaller. No, I take it back. Smaller, large intestine too, but let's just stick with the stomach. I'm an organic chemist. I never took A&P, anatomy and physiology. Not that there's anything wrong with it, but I'm an organic chemist. All right, so you should know, eat a fat or oil, how to describe it with words, acid, hydrolysis, and ester. If you have an ester, the general reaction, acid and water, get back the carboxylic acid plus the alcohol you would have used to make that ester. And you should know how to describe with words and a general reaction when you eat a carbohydrate. And the linkage holding the carbohydrate, holding the starch carbohydrate together is an acetal. Acid hydrolysis, remember water and acid in your stomach, acid hydrolysis of an acetal. And the general reaction is, if you take an acetal or ketal, R prime can be H or carbons, acid and water, you get back the aldehyde or ketone plus the alcohol you would have used to make that. And with that, I'm done for the evening. I'm going to stick around for a couple of minutes. If anybody has any questions, I'll answer them. If you want to stick around, remember, Wednesday morning, I will send out the email with the password for test 4 and D2L. Because of Thanksgiving, you'll have until Monday, December 2nd to finish test number 4. Yeah, you'll have sometime by the end of Tuesday, hopefully I have another class I'm giving a test and they're due Monday also. I'll get it next Wednesday or even possibly Thursday. I'll have a answer session for test number 4. I'll send out an email. And with that, don't forget the extra credit deadline is this Tuesday, December 2nd, or Monday, December 2nd. And before that, before you upload if you're going to do the extra credit, and you should, it's 10 points. It's not that hard. Send me by email your project. I will check to see if it's okay. If not, I'll tell you what needs to be corrected. Don't tell anybody I'm being nice. Ruin my image around here. But anyways, and I'll do that. With that, I'm going to wish you a happy Thanksgiving. Hopefully you all have a great Thanksgiving. In my family, the turkey isn't the only thing that gets stuffed. We all do. Anyways, with that, I'm going to say Gang Gesund, which means go in health in Yiddish. And you know what I'm going to do next. Bye now. I stole that from Granny and the Beverly Hillbillies. Bye.